Orange rock, orange sky, light with no shadows. So what is missing from this picture? This is Venus, photographed from the ground, and the air here weighs 92 times what Earth's air does. An ocean. That is what the chemistry points at. The hydrogen in this planet's air carries the fingerprint of water lost on an enormous scale. The heavy kind, here, runs about 100 times richer than on Earth. But the body that fingerprint belongs to has never been found. 10 Soviet landers have reached that ground. Stand where they stood, and your time is measured in minutes. None of them lasted longer. Press a hand flat on a table and lean on it. That is 1 atmosphere. Down there, the air presses like seawater at 900 meters, and it is hot enough to melt lead. Nobody has ever brought Venus rock home. Every claim about its water comes from instruments reading it from Earth, from orbit, from inside the clouds, or from a lander on the ground. The first of those numbers came from one instrument on one December day in 1978, a probe falling through the clouds with a mass spectrometer aboard, and the measurement very nearly never arrived. The probe sampled air through narrow metal inlets while the pressure climbed around it. Somewhere below the cloud deck, those inlets stopped behaving. Sulfuric acid droplets out of the clouds had coated them. To anyone reading the telemetry, that looked like a failure, a blocked line, a ruined water measurement. Put yourself at that desk with the numbers coming in. You have one probe, one descent, no second chance, and a channel that is reading something it was not supposed to be reading. Fault or measurement? The answer turns on a detail about water. Not all of it weighs the same. Swap one hydrogen atom for its heavy twin, deuterium, and the water gets measurably heavier. Every ocean on Earth carries a little of it. Break water apart high in an atmosphere and the light hydrogen leaves first. The heavy kind lags behind. Do that long enough and the air keeps the count of everything that left. Venus is enriched by a factor near 100. Something took the hydrogen and left the deuterium standing, and there is no gentle way to leave that much behind. In the heat under the clouds, the acid coating broke down and gave up the water locked inside it, so the instrument tasted a sample nobody had designed it to take. Then wait 4 years, because that is how long it took to reach print, and what arrived was 3 words long. Venus was wet. It was not one instrument's quirk. 9 years later, ground-based infrared spectroscopy looked at the same air from Earth and came back with 120, plus or minus 40. 2 methods, 9 years apart, same answer. Water left this planet. The next question is the one that decides everything. How much of it was there? Stand on that plane and put the water back over your head. 4 meters deep, or 525, or at the very top, a full Earth ocean. A film at one end, a sea at the other, and a sea leaves marks. That spread is not sloppiness. It is what the measurement allows, and its 2 ends are a damp rock and a blue planet, which means the claim was born in a fault. The number everyone repeats about Venus came out of a sensor that stopped working the way it was meant to, and nobody planned the measurement that made it. So the ratio is solid. What the ratio means is not. To find out what an ocean would have done here, a group of modelers put one back and ran the planet forward. They gave it a shallow ocean covering about 60% of the globe, a nitrogen atmosphere, and the slow rotation Venus actually has. Slow rotation matters. It builds one enormous cloud deck on the day side. The model came back with a global average of 15 degrees Celsius and snow on the highlands all year round. The mild phase holds until about 700 million years ago. If the model is right, this system had 2 temperate planets in it, side by side, for most of its history. But a model is not a coastline. If water stood on this surface for 1 billion years, it left a shoreline somewhere. So where would you look for it? We are not short of maps. A radar mapper reached Venus in August 1990 and stayed for 2 years, covering 98% of it at 75 meters per pixel. A drowned shoreline is not subtle in radar. It leaves wave-cut terraces, sediment platforms, deltas where rivers ran out of slope. On Earth, you can trace them from orbit. On Venus, none of it turns up. The closest thing anyone offers is the crumpled boundary where the old highland terrain meets the plains, which looks a little like a flooded edge. That is a resemblance, not a record. The wet model has a second problem, and it comes from inside the field. Venus today carries 92 bars of carbon dioxide. Nobody has shown how a 1-bar nitrogen atmosphere becomes that without leaving a chemical trace behind. Stand in the model for a moment anyway. Snow is coming down on high ground, the air up there is thin and cold, and the sky is pale. Then read the label under the picture, because it says model output, not photograph. Somebody did try to go and look. Between 1970 and 1985, the Soviet Union landed 10 craft on that surface, and the longest of them held out for 127 minutes. Long enough to photograph a plane. Nowhere near long enough to find a coastline. The first one to work touched down in December 1970 and transmitted for 23 minutes. Nothing had ever landed on another planet and kept talking before. They were built like submarines because that is the engineering problem they were solving. Titanium pressure vessels, double-walled, sealed shut, with the instruments packed inside a sphere that had to hold against 90 atmospheres. One of them settled onto a plain of dark rock on the 1st of March 1982. The gauges read 460 degrees Celsius and 92 atmospheres, and the camera started its sweep. It was designed to work for about 32 minutes. It ran for nearly 4 times that, which makes it both the great success of the program and the measure of the limit. Nothing since has done better. There was no lens on that camera. A mirror rocked back and forth, sweeping one line at a time. Everything on these machines was built around one question. How long does the planet let you work? And that color is not a stylistic choice. Sulfur in the clouds takes the blue out before the light gets down there. The orange is what your own eyes would do on that plane. One of them also carried a microphone. Put the recording on and what you hear is wind moving across a plane nobody has walked. It is the first sound ever captured on the surface of another planet. But every one of those lifetimes is counted in minutes. Not one machine lasted long enough to walk a shoreline, or to map one, or to bring you back a rock. The surface was never going to answer this by itself. So the question moved. Instead of asking what is on the surface, the field started asking how old the surface is. That answer came from counting craters. Count the impact craters on the whole planet, and you stop at about 900. Most of them are undamaged, and they are scattered at random, which means the entire surface is the same age, 500 million years, give or take 200. The record was not destroyed, it was paved over. Which is strange, for a planet 4.5 billion years old. 9/10 of its history left no visible record, none at all. Work out what that does to the case. A beach from 1 billion years ago, a river delta, a layer of sediment, any of it would now be under basalt or gone. And the resurfacing was not gentle housekeeping. Lava flows cover more than 85% of Venus, yet only 2.5% of the craters have been flooded, which says the flooding happened and then largely stopped. If the record is unreadable, the question has to change. Not where the water left its mark, but what it was doing while it was here, and and what broke when it went. There are two ways to resurface a planet. Heat builds under a rigid shell until the whole outer layer founders at once, or volcanism trickles on steadily. Steady models predict at least 17 times more flooded craters than anyone can find. Run a boot over that ground. Flat slabs with sharp edges, broken plates of cooled lava, nothing rounded, nothing sorted by size. No water ever moved a single one of these stones, and yet this planet has rain. The cloud deck sits between 48 and 70 kilometers up, and it is not water. It is sulfuric acid, thick enough to keep the surface out of sight, which is why nobody saw the ground until a probe went down into it. Droplets form in there, and they do fall. This part of the story is real, and it is the part every documentary keeps. Then, still about 30 kilometers above the ground, in air already past 400 degrees Celsius, they finish evaporating. Meteorologists have a word for rain that never lands: virga. So the famous image of acid storms scouring rock is wrong. Nothing down there has been wet in a long time. What came down from those clouds was not rain, but a claim. One line of phosphine, read in 2020 as a sign of life. It did not hold. The line came apart on reanalysis, and sulfur dioxide sits in the same part of the spectrum. A world with no liquid on it cannot round a pebble the way a river does, or lay down a layer. Whatever is poured out mostly stays as it was poured, which is why the surface reads like a fresh cast rather than a landscape with a history. Look for your own shadow on that ground. You will not find one. The light arrives from everywhere at once, strained orange by the clouds, so nothing down there has an edge. No shadow to tell you how tall a rock is or how far away it stands. Tilt your head back on that plane. There is weather up there, 50 kilometers above you, falling toward you and finishing 30 kilometers short of the ground. Nothing has ever landed on your boots. And if the wet model is the right one, this plane would have been seabed, with the light dying overhead long before it reached you. A dry surface is one thing. A dry interior is another, and the interior is where this case turns. Why would the inside of a planet stiffen just because the outside lost its water? On Earth, the ocean does not stay on top. Water works into the crust, and where plates dive, it rides down with them, into the mantle. 3 billion years of ocean would leave you a wet interior. And water and rock behaves like oil in a machine. It lowers the viscosity of the minerals and the stress they can take before they slide. Dry the mantle out and the rock gets strong in the worst possible way. Strong rock will not subduct. Nothing subducts, so there are no plates, and the cycle that pulls carbon dioxide out of the air and files it away in stone never runs. Every eruption after that adds carbon to the sky, and nothing takes it back. The 92 bars overhead are the receipt. If plates ever moved here, losing the water is what stopped them, and that door has no handle on the far side. Notice that this chain works either way. It never required a sea. It only needs the water to have been in the air and then gone, which every reading of the ratio agrees on. Which brings up the reading nobody puts in a trailer. The ratio is real and the water is gone. But suppose the water was never an ocean. Suppose there was no body at all. Start with a number that gets skipped. Water does not last in that atmosphere. Against the escape rates being measured, its lifetime up there is on the order of 100 million years. So where is today's water coming from? So the water in the air today cannot be left over from the beginning. Whatever is up there arrived recently, in geological terms, and something is still delivering it. Comets are the obvious supplier, and comets are rich in deuterium already. Feed a planet with comet water while it steadily loses the light hydrogen, and you can hold a high ratio for billions of years without ever filling a sea. It is the thinnest of the three arguments, and also the hardest to rule out. At about this point, almost every account reaches for the same explanation. Venus has no magnetic field, so the solar wind stripped it bare. It is tidy, it is repeated everywhere, and it does not survive the measurements. Earth has a strong field, Venus has none, Mars has the remains of one. All three have been measured. The escape rates land between 0.5 kilogram and 2 kilograms per second. Being shielded is not what decides it. Go up to the place where a planet stops being a planet, the last thin shell of air before space. Above Earth, that shell runs near 1,000 Kelvin because magnetic energy piles into it. Above Venus, it barely reaches 200. The shield does not seal the exit. It heats it. A magnetic field also opens a road of its own. Over the poles, field lines run out into space and carry ions with them, which is a lost channel a planet without a field does not have. So the tidy explanation has it backwards. A magnetic field is not a lid on a jar. It was never what kept Earth wet, and its absence is not what emptied Venus. What did empty it is duller and far larger, and it was working on both planets at once. It is the sun, and the mechanism has a name and a measured rate. Ultraviolet light does not warm a water molecule. It takes it apart. High in the atmosphere, the bond breaks, and the hydrogen is free to leave on its own. And the young sun was not this sun. Its output at the shortest wavelengths, the part that does the breaking, ran 100 to 1,000 times higher than today. Push enough energy into the top of an atmosphere, and it stops leaking and starts blowing. The outermost air heats to thousands of degrees and streams away as a planetary wind, dragging light hydrogen out more efficiently than deuterium. How fast that emptied the planet comes down to one thing: how long Venus stayed molten at the start. Freeze early, and water condenses, and the loss takes billions of years. Stay molten, and the water never condenses at all, and it is gone inside the first 100 million years. And the dry reading has a measurement of its own, published in 2024. Work out how much water Venus must be venting to keep its atmosphere stable, and the answer comes back at 6% of the volcanic gas, at most. On Earth, the figure is 60 to 90. The planet's own breath is dry. 2 of the 3 readings do not need an ocean, and the one that does still cannot show a coastline. Here's where the file actually stands. 1 measurement nobody disputes, and 3 histories that all fit it. A shallow sea that boiled away, a planet too hot to ever condense one, and a ratio held up by comets with no sea anywhere. The honest answer is that we do not know which. 3 readings, 1 number. If you had to put money on one of them, which would it be? That is not a rhetorical question. It is the question the next decade of Venus missions was designed to settle, and there is a measurement that can do it. First, the scale of what we are working with. Crouch beside Venera 14 in March 1982 and watch the spring-loaded arm swing down. The arm was built to test the soil, but the lens cap, fired off on landing, is already lying on the exact spot the arm reaches. Of 57 minutes of working life, the soil reading went to the lander's own debris. So nothing here is going to be settled by digging. It has to be settled by reading, which means finding a piece of Venus that the paving never reached. Is there one? There is. High, crumpled, folded terrain, roughly 1/10 of the planet, standing above the plains. The plains run up against it and bury its edges, which puts that terrain underneath, and it is still there. with one caveat that matters. Count craters on it, and you get the same age as the rest of the planet. It is called the oldest because of what lies on top of what, not because the counting says so. And it looks different in the infrared. That terrain glows faintly at those wavelengths, and that faintness fits a rock family the plains do not belong to, granite, the kind Earth makes where water works on rock for a long time, which matters because of how granite is made. On Earth, you get it when basaltic crust melts in the presence of abundant liquid water. Granite is not a hint of water, it is close to a signature. Keep one more clock running while we get to the answer, because the rock is not the only thing changing. The sun brightens by roughly 1% every 100 million years, and it is doing that to both planets, which raises the question this video has been putting off. Back to the rock. There is a mineral called tremolite that only forms where water is, and in chambers built to imitate Venus, it breaks down slowly enough to still be there after a geological age, which puts something specific on that high ground. Stand on the oldest thing still showing, above the plains that buried everything else. What you came for is not a view. It is a crystal, and the water may still be inside it. Being consistent with granite is not the same as being granite, though. Low emissivity is a hint from orbit. Read down through more than 20 kilometers of acid cloud. Nobody has read that rock, and from where you are standing, nobody can. So 3 missions are being prepared to go and read it properly. Not launched, not on their way. Still years from the pad. 2 orbiters, Veritas and Envision, are designed to map that glow across the highlands and to see under the surface with radar. Between them, they can put the granite reading to a real test from orbit. And the 3rd one goes down. Because there is a second archive on this planet, and it is not made of stone. The air keeps one too. Noble gases react with nothing, and the heavy ones are the hardest to lose, so the atmosphere still carries traces of the mixture it started with. A probe called DAVINCI is designed to fall through it and read them on the way down. The launches sit in the 2030s, which is an unusual kind of comfort. The answer to what happened here is on a schedule, and the schedule fits inside your working life. At most, one of those 3 histories survives that air. And whatever that probe reads, the planet is still moving. On Mont Mons, a vent went from about 2 square kilometers in February 1991 to 4 by October, filled to the rim. Nobody noticed for 32 years, because finding it meant comparing overlapping radar passes by hand. So here is the answer to the question this opened with. This planet lost water, an enormous amount, and it is still losing what is left. What nobody can produce is the body. No coastline, no delta, only basalt. Notice what that leaves standing. Take the wet model at its word. This ocean sat here for most of the planet's history. Then anything that started in it is under that same unread basalt. So the comparison everyone makes has the wrong villain in it. Earth sits about 40 watts per square meter below the runaway threshold, and carbon dioxide closes that gap in ever smaller steps. Reaching it would take something like 1,000 times the pre-industrial level. Burning every accessible fossil fuel gets you to 10 times, not 1,000. We cannot do this to Earth. The sun can. At that rate, the calculations give Earth another 1.5 billion years at least. After that, the same sequence runs here. Humid greenhouse, water loss, a thermostat that stops turning, a lid that stops moving. Not a warning. A rehearsal we get to watch from outside. Go outside the next time it rains and let it land on you. Earth sits 40 of those watts below the line, and above that line the water leaves. walk into the room where it will be put together. The thing you are waiting on is 3 numbers wide, isotope ratios taken on the way down, off a probe that has not flown yet. Stand at the end of that decade and look at what arrives. 1 probe, 1 descent, and the first real chance to read what is lying under air 92 times heavier than the air in your lungs. The file stays open on your side of the desk, but nothing in it is soft. That water is not coming back. The door it left through closed for good, and the same door sits ahead of ours. The near half of that question is closed. Nothing we know of holds together in that heat. The far half is written in basalt, waiting on 3 numbers, and the mission that would read them is planned for the 2030s. Orange sky above orange rock. 1 ratio and an ocean nobody can find. What is known, we showed you. What is not, we marked. The other open files are on the channel.